Well, here is the next screencast where we're supposed to find the friction of the guy sliding on ice and for the car sliding on the ice. So, for the guy, it was known that the initial frame was 30, the final frame was 110, the rate is 30 frames per second, V final was 0 meters per second, and distance was 7.5 meters. Unknown was A, time, VI, average V, and coefficient of friction. Next, I drew a free body diagram. You could see there the normal force up, friction force holding him, pulling him back in the direction that he started coming from, and weight pushing down, force of weight. Okay. So from there, I decided to find time first. It's the most simple one to find. 110, the frame final. Sorry, the final frame. 110 minus 30, the initial frame, and that equaled 80 divided by 30, which is the rate, and got 2.67 seconds time. From there, I took V average equals distance divided by time, which is 7.5 meters divided by 2.67, and got the answer of 2.8 meters per second. So from there I got the equation V average equals V initial plus V final divided by 2. Whereas V initial equals V average 2 minus V final. Once you rearrange the equation to get the initial velocity. So V initial equals 2.8 meters per second 2 minus 0 meters per second. V initial equals 5.6 meters per second. Then to find the acceleration, V final minus VI over TF minus TI, or delta V delta T, equals 0 minus 5.6 meters per second over 2.6 minus 0 seconds, equals negative 2.08 meters per second squared. Which makes sense because he has a negative acceleration, he is slowing down. So from there, the coefficient of friction equals negative MA after rearranging the problem, and also N equals W, which is the normal force, equals the weight, which also equals mg. The coefficient of friction is equal to kinetic friction over N, equals negative MA over mg. From that, you could cancel out both of the m's, leaving you with just negative 2.08 meters per second squared over 9.8 meters per second squared, which equals 0.21. And there is no label because friction is dimensionless. From there, moving on, the car on ice is known that the initial frame is 55, the final frame is 140, the rate is 30 frames per second, and distance is 8 meters. V final equals 0. Okay. The unknown is the acceleration, initial velocity, time, and coefficient of friction. Free body diagram is located there. Normal force up, kinetic friction is back, and the weight is down due to gravity, the gravitational force of the Earth. Alright, so time, the first one I find is 140, the final frame, minus 55, the initial frame, equals 85, and that is divided by 30, the rate, which equals 2.83 seconds. So the average velocity is equal to 8 divided by 2.83, which is distance over the time, and that number equals 2.82 meters per second, which is the average velocity. From there, it is easy to find the initial velocity with the equation average velocity equals v initial plus vf divided by 2. After rearranging the equation, v initial equals v average 2 minus vf. And plugging in the variables, 2.82 minus 0 meters per second equals 5.64 meters per second for the initial velocity. From there, I tried to find the acceleration, which is v final minus v initial, divided by the final time and minus the initial time, delta v over delta t, which is 0 minus 5.64 divided by 2.83 minus 0, which equals negative 1.9 meters per second squared. From there, I find my last unknown, which is the coefficient of friction by friction, or the force of friction equals the negative ma, and also N equals W, which equals mg. So therefore, the coefficient of friction is equal to the force of friction divided by N, which is negative ma over mg. The m's both cancel out, leaving 1.9 meter per second squared over 9.8 meters per second squared, which equals 0.19 for friction, which is dimensionless, so you just leave it as coefficient of friction is 0.19.